right? Because you could also have a, you know, something going up like this, and then it takes off like that. Well, that ain't a maximum. No, well, it's a it's a relative maximum, but it's not an absolute maximum. What would be a better way to do it? Hold on. I could do that. That doesn't make a maximum minimum. Actually, it does. It makes a relative maximum, relative minimum. I can't make one. Apparently, that does make them so. But the point's still the same. I got an open circle. It goes like this, and like this. If I don't check my endpoints, because they're not part of the graph, right? I would find that's my absolute maximum, that's my maximum minimum. Are they? So I have to check those endpoints, even if they're not there.
Just if you're trying to find maximum minimum.
Absolute. No. Only if I have to find absolute. By the way, I don't need to check them if I just want to know if that's relative. Yeah, I don't need these at all. It's when I want to say they're absolute maximum, the absolute minimum, that's when I have to check the endpoints, even if they're not there. But they're not critical. They're not called critical points. You can't. If they ask you what are the critical points, those points are not points on your graph, so they can't be critical points. Yes. Now they'll take points off if you don't check them. When you're looking for absolute maximum, maximum minimums. If you're looking for relative maximum minimums, they can care less if you're looking at them. They wonder why you're bothering. But if they ask you what are the critical points, you cannot list ones that are not there. So, well, it's good they define it this well, because otherwise we'd go to the test and be guessing what it is that they want in this particular case. But yes, there is some hokey math going on there. Yes?
On 11, are 1 and 3 both absolute maximums?
Yes, they're both absolute maximums. You have a lot of absolute maximums as it works. Okay, number 12's got a trick in it, so Strats will like this one. Strats, what do you got for me?
I got, in little parentheses, 0 and 6-ish.
Those are not ish. You would have to check those, but they're not critical points.
Yeah, but they're also like not on the point. That's why I put them in parentheses and check.
Oh, okay.
And then 5, maybe?
I would say 5 and
well, I don't know.
2 is also a critical point. The slope would be 0 at that point. It wouldn't be a maximum or minimum, but there would be a critical point there, right? The slope would be 0.
So it looked nearly 0.
Okay. Well, I would say, since they said approximate using the graphs, I would say the slope there is 0 and therefore it's 2. If you were certain the slope was not 0, then maybe you could argue over that. Yes? I would say the only two are x equals 2 and x equals 5 are the critical points. And if I was asked for absolute max and absolute minimums, I would have to check that against x equals whatever those 2 points are. They're not quite perfect to be complaining about. All right, let's do some real stuff. Let's do number 13. Find any critical numbers for this function. Go. Ready for this one? Everyone else ready? Okay, we're ready? Okay, here we go. I'm going to go f prime of x. First of all, I check endpoints. No endpoints. No discontinuities that I know of. Therefore, there's no critical points because of that. Next thing I'm going to check is, what's the derivative? The derivative is 3x squared minus 6x. You're a sucker if you did it as a product rule. Good luck with that. So now I'm going to go ahead and set it equal to 0. 0 equals 3x squared minus 6x. Factor out a 3x. I get x minus 2. I get x equals 0 and 2. Great. So my critical points will be found at x equals 0 and x equals 2. Is there any other critical points? I got nothing. Now, if I want to declare one as an absolute maximum and absolute minimum, I have to check negative infinity and positive infinity because those are always endpoints if you don't have other ones. But for right now, these are the only 2 critical points. I am done. Got it? Boom. Find me some more critical points for T, number 15. This would be better if it said less than or equal to 3. Then I'd have something fun to play with. But it says less than, so we'll just stick with it. 2 things multiplied together. Uh-oh. Wait. This one's going to take a little work.
What happens?
Where it's undefined. That's also a critical point. What?
Isn't that when it's
Yeah, it could be, yes. Could easily be.
That's not a critical number.
That's not a point that's on our graph, which is a bummer because it'd be nice to have it in there, wouldn't it? Too bad. Trying to be nice to you.
So if you're looking for critical numbers, does AP Central still want you to consider the endpoints?
Yes. Critical numbers have endpoints as long as they're really there.
Okay,
See,
if they're
because
not-
this is not really there, you don't count that.
Okay, so you don't even consider that.
But if
then?
it's, no.
Okay.
If you want to find absolute, you have to consider the points that are not there.
Okay, yeah.
If you don't, if it's just relative maximum, relative minimum, you don't even have to look, you don't care. Because an absolute value, absolute maximum is also a relative minimum or maximum, right? So you're okay. The only time you have to check that is when they were looking for an absolute something, or rather you need to check those endpoints that are not there because they could be higher than your high point, in which case you don't have one. Again, we're micro-focusing on something that hardly ever comes up. Yeah. Yeah, I got to tack on a chain. I haven't gotten there yet. I was mid-sentence when I need a -1 here, I believe. Am I right? Usually when I stop halfway through a problem, I guarantee don't know what I'm doing. The t still sitting here, I believe. All right, so I get 0 equals, I've got square root of 4 minus t plus t over 2. That's not a plus, it's a minus now. Love it. Minus t over 2, square root of 4 minus t. I've got that now for fun. Good news, I can move it to the other side. I get t over 2 square root of 4 minus t equals square root of 4 minus t. Multiply both sides by square root of 4 minus t. I get t over 2 equals 4 minus t. Woo! Starting to sweat. What are you wrong?
Sorry, I need to go back to the second step. Yeah, multiply times negative 1.
I got to put a -1 here because when I take the derivative of the inside. I chain ruled it.
Is there two, right?
There's a t on front, right? Because in a product rule, it's going to be the first one times the second one unchanged, plus the first one unchanged times the derivative of the second one, which means I throw the 1/2 out in front. 4 minus t to the -1/2 times the derivative of the inside, right? And then I clean it up so it looks like this and set it equal to 0. I would note the following, that t equals 4 is where it's undefined. I should have said that, but then again, that's bigger than 3, so it doesn't matter. Because it says t is less than 3.
No, I'm just saying why is it undefined?
Oh, what if I put a 4 in here? Doesn't the bottom go to 0? Yeah, so we should check. That should be a big flashing light on our dashboard. Ah! Also, by the way, when the square root becomes negative. 4 or bigger becomes negative. Aha, it's another place. But there's 2 reasons why there's a flashing light, but it doesn't matter because it's bigger than 3, so who cares? But that, I should have said that. I had a long conversation with Welco, that's why I didn't. And I should have said it to the whole class. You guys good? All right, so then I would move that over here. I'd move that up there. Distribute the 2 through. 8 minus 2t. Move that t over. I get 3t equals 8. And I get t equals 8/3, and that would be where a critical point would be. It's the only one I have because everything else is above 4. 3, yes, ma'am.
But since
Is that bigger than 3 too? No, it's not. Ah.
okay.
I'm about to have a moment. Yeah. I'm sorry. I apologize. Get it on a piece of paper, though, and you're free to use it as much as you like. All right, everybody do number 19 on the back. Go.
Wait, what about 17?
You guys want to do 17?
Yeah.
We should do 17. Let's do 17. Then we need to do the other one on the back. Okay, so here we go. In this problem, I've got to find the absolute maximum. So I need to find all the critical points. First thing I do is look at my function. Mr. Manuelos, in your expert opinion as mathematician, is there any place where this thing goes undefined on me?
No.
No. But there are endpoints now. So to set up my table, I'm going to have 0 and 3 on my list of critical points. Right?
Sure.
Okay. Now I'm going to go ahead and take the derivative of this, find out a place where it's undefined or equal to 0, right?
Yeah.
So any place where this would be undefined. No, that's not undefined. So now I'm going to set it equal to 0. Negative 3 equals negative 2x. X equals 3 halves. Do you have that down?
Yeah.
Okay, so I got 3 halves. Now how do I check to see what my absolute maximums and absolute minimums for this stretch?
You plug in those numbers.
Just plug in the numbers. I plug in 0, I get 0. Plug in 3, negative 9 plus 9.
Wait, you're at negative 9 plus 9.
Wouldn't that be 0?
Yeah, 0.
Okay. And then I plug in 3 halves, and I get negative 9 fourths plus 9 halves, right?
Yeah.
And that's going to give me 9 fourths. So this becomes 9 fourths. So what would you say, where are my absolute maximums located in terms of x? What does actually the point say? What does it say? It says locate the absolute extrema of the graph. So at x equals 3 halves, we have a what? Absolute maximum. Because we've eliminated all the possible places it could be. At x equals 0 and 3, we have a what? Absolute minimum. Got it? Can do this for homework? All right. It's all yours to do then. Have fun.